Hello Math 8 students! This is Open Up Resources Unit 1, Lesson 15, Adding the Angles in a Triangle. This is part 3 of our 3-part video series for this lesson. To quickly review the things that we have learned in our other videos. We started by reviewing triangle vocabulary and just learning some more about triangles. We learned obtuse are greater than 90 degrees, right angles are exactly 90 degrees, and acute angles are less than 90 degrees. We saw scalene means all side lengths are a different length, and we were able to create an obtuse, right, and acute scalene triangle. We saw isosceles meant two side lengths are the same, and we were able to create an obtuse isosceles, a right isosceles, and an acute isosceles triangle. And we also learned that equilateral means all three sides are the same length. And we saw that we can create an acute equilateral triangle. However, it was impossible to create an equilateral right triangle and an equilateral obtuse triangle. After that, we looked at different triangles and saw that each one of the triangles all had angles that added up to 180 degrees. Here were the 5 different triangles and each of their angle measures, and every one of them added up to 180. We asked the question, is it just these triangles or is it all triangles? In our second video, we did an experiment where we printed off these triangles, or we used a digital manipulative to test out and see if these triangles also had all angles adding up to 180 degrees. And we did see that that was the case. All 3 of these triangles had angles adding up to 180 degrees. Our next activity is going to further solidify that that does happen each time. What we're going to do this time is, instead of starting with a triangle and measuring the angles, we're going to start with these 3 angles that we know for sure add up to 180 degrees and see if we can use them to build a triangle. When we take a look in Canvas, you will see here's our first video and the corresponding lesson, including the answers. Here's the second video, the corresponding activity. Here we are at the third lesson, the third part of the lesson in the third video. When this video is done, it's going to go right here. Again, you can print this page. When I click on that, it does take me to the same page that it took me to before. Remember this 2-page document? Now we're going to focus on that first page. If you already printed it the day before, you can just use it from the day before. If you haven't printed it yet, again, there is a digital version, so you can use the digital version. Here is that digital version. Same as before, if you're using this digital version, when you click on this, and again, I'm going to click on it incognito so that it doesn't know that I'm already logged in, you will just click on it, and it will pull up the PowerPoint. But again, it reminds you that it is read-only. So you have to go to File, Download As, that way you're downloading it to your own device. Make sure you're downloading a copy. Don't choose any of these other images, it won't make it editable. Download a copy. It says the presentation is ready, so we download it. Here it pops up. You, depending on your browser and depending on your system, you might have it pop up somewhere else. Open up that download. And then this is an editable file. We'll return to the editable file later. Please make sure you remember to download and save your own copy. Continuing on with this lesson, this is Tear It Up Part 2. Again, your teacher will give you a page that's printed, or you're using the digital file. And what we're going to be doing this time is we are asking the question, can we now take these 3 angles that for sure are 180 degrees, and I know that they're 180 degrees because they all line up perfectly, creating that nice straight angle, and 60 plus 60 plus 60 is 180 degrees. The other ones are not labeled, this is the example. But can we take these and turn them into a triangle? Okay, so this is what this looks like. I'm going to model it first with this set of angles here. Then I've got a set of angles that I have on paper that I will physically cut and demonstrate for you, and then you'll be doing it on your own with the other angles. Here's these 3 angles. As I cut them, I'm going to just separate them and split them apart. Here's what they originally looked like, but I have cut them. Notice they do have the marking system just like we had before. These are arcs. On my paper one, I'm going to color it, and on these other ones, you have the little different icons to show what those angles are. So I'm going to try and create a triangle. And when I'm doing this, I'm going to say, oh, look, I can line those up to be a nice straight line. And this one, I'm going to have to probably rotate so I can make a nice straight line here as well. As you're doing this, notice that sometimes they might overlap, and that's okay. There is a triangle that worked out nicely, but sometimes it's not going to be quite so obvious. So I would at least line those up. And even though it's not a triangle right now, all I have to do is connect it with a line to see that it is a triangle. Now I know I need to actually get that into a little bit better position to make it form pieces of that triangle. And now I know that this is probably going to have to go somewhere up here, and I'm going to have to continue those lines to actually form that triangle. So there's that line. Here's this line. And so I need to move that angle a little bit further away to make it line up. There we go. And now I can see this beautiful triangle that I was able to create using each of those three angles. Okay. Again, it is going to look a little bit different for each one of these, but please be aware that even though right now it's not a triangle, they're all spaced out, I can see that if I just extend that line, I can connect those two angle pieces. Think back to the last activity where we cut off the corners and then threw away that middle piece. We're basically recreating that middle piece that we threw away. Now let me show you how to do this in person. If you're physically cutting them, we would have something like this. Now again, this is not one that is on your paper. This is one that I have created, but the process is the same. Here's that straight edge. So I'm going to first start by cutting, and just like I mentioned in the last video, make sure that you're cutting, leaving yourself enough space so that you can actually see that line. Okay, again, I'm going to be cutting so that I can see that angle, and cutting so that I can see that angle. Now I do have these really weird shaped pieces at this point. So what I would do is, why don't we sort of cut them out so that I can actually pay attention to that angle a little bit better. I don't need all of that extra stuff. I'm going to put that off to the side. You can just cut straight across like that if you want to, but it's probably also a good idea, just to make sure we're focused on the correct angle, go ahead and cut in. Notice that where I'm cutting, I'm leaving the icon alone, and I'm just kind of cutting into the angle there. Last one. Cutting into the angle so I can focus on the angle. Getting rid of all of those scraps. Now I'm going to bring in a sheet of paper here because I don't want to draw on my desk. So I've got these angles, nothing's lining up right now. Just to get started, why not line those up so that it creates a line? And now I can twist this into place, try and line it up, and look at that, I didn't even actually need to extend those lines anymore because that worked out perfectly. Now if I wanted to though, if I wanted to make my triangle bigger, maybe I will spread them out a little bit, and see, there's the line. Let's spread that out, which means now I need to get out that straight edge to extend that line. Now I can see that triangle forming. Same thing, since I know that these probably aren't going to fit in there very nicely, maybe I'll just go ahead and extend that line now. Oops, that one fell off. So now when I pick this one up and I try and get it in place, I know that it would have to line up on that side there. If I pull it too far away, it's not going to line up, so I've got to push it in a little bit closer so that it lines up with that other side. Looks like that twisted just a little bit too much. There we go. And it looks like, yes, we were able to create a triangle with that. So I know that there is a gap. That's okay. just like we cut out our angles and then ignored the inside part, we have just our angles and we have to recreate that inside part. So this is that inside part that we would have cut away. So there's how we would do it if we're actually physically cutting. And I will also do the first one with you using this digital version. So remember, we saved this PowerPoint and I'm going to cut them, which means enable editing. Forgot about that step there. I'm going to cut these, so I'm just going to be sliding them apart to show that I've cut them apart. Okay, this is just to remind us what it looked like originally. Now I'm trying to form a triangle. Looks like in order for it to be a triangle, I'm probably going to have to rotate that piece a little bit. Looks like that'll line up nicely. Maybe you want to squish them together. Maybe you want to keep them far apart. That's up to you. Now I know that in order for me to get that to line up and that to line up, I'm probably going to have to start rotating this side. This one is going straight up, so I'm going to keep on rotating until this angle is going straight up. Now again, is this forming a triangle perfectly right now? No, there's some gaps. So we'll probably have to insert some lines in order to make it all work perfectly. So I would go Shape, insert the line, and then let's actually draw that line. That was very light blue. Not sure if you even saw that. Let me see if I can make that a little bit thicker. Okay, so now I've extended that line, and let's continue on. Let's add in another insert shape line. Let's extend this line too. And again, same thing. It's very, very thin, so I'm going to increase that weight so that I can actually see it a bit better. And it looks like I was pretty good at eyeballing where that would be, but not quite. So let's continue to move it into place. And of course the technology is fighting against me and I can't get it exactly where it needs to be. Still not a triangle. Let's finish up that last side. So insert shape, line, extend that line. Uh-oh, it's not making a triangle. Does that mean that it's not working? Does it mean that everything is completely wrong? Nope, it just means you need to play around with it a little bit more. I need to pull this back a little bit further. Looks like I can maybe squish this in a little bit. Oh, there we go. It's looking a little bit better now. Squishing that in just a bit more, squishing that down, and now it looks like I'm able to create that triangle. So you just have to play around with it a little bit, but you can form that triangle. Your job is to do it with the other two, whether you're doing it digitally or you're physically cutting out, just like we see here. Pause the video until you have created triangles with your other two remaining icons. Sun icon was done, cloud icon you need to finish, and the X icon you need to finish. Pause the video until that's done. All right, now that we're back, let's take a look at what these triangles could have or should have looked like. Now again, I'm going to take advantage of the fact that I already know the structure. When I cut these apart, do you see how this has a nice straight line on the bottom? Do you see how this one has a nice straight line on the bottom? Why don't you form that by starting to line those up? That already gives you a clue as to what the triangle could look like. Keep the same base as what we already created here. This last piece cut out, you can see that in order to make this work, I am going to have to rotate it. And when I rotate it into place, okay, notice when it's back here, it's not going to form a triangle, but if I start moving it down, keeping that line lined up, you can see that eventually it does line up. I didn't have to extend those lines. Maybe you did. You could have made your triangle a bit bigger, which means that maybe we would have had to extend those lines. Back here is probably where it will line up and we would have to extend those lines. I don't want to have to worry about that because I'm limited with my technology, so I made a little bit smaller one. The last one, the X icon, again, cutting those out, and as I cut them apart, remember that base. Why not just form a triangle with the same base as what we already started with? That will be a big help to you. So I'm lining those ones up and seeing that this angle is going to have to be rotated into place. Looks like I rotated a little bit too much. Going back, that looks a little bit better. And we can see it does form a triangle. So what if there's a little bit of piece left over and a little bit of piece left over? Just like we can create pieces, we can get rid of those pieces too. And we can do that because we're just focused on the angles. We don't need to worry about the side links. We're just focused on the angles. So does it work going the other direction? If I take any 180-degree angle, can I still make a triangle? Maybe you're a believer, maybe not. What you need to do now is make your own. Again, use a straight edge to create 3 of your own angles. So just like I did on my yellow post-it note, I would start by creating a straight line that shows that 180 degrees, and then I would split it up. There's one angle, there's 2 and 3 angles. And so then I would cut them up. Can you make a triangle? See if you can prove it false. See if you can create 3 angles that are 180 degrees that won't form a triangle. Go ahead and give that a try. Pause the video until you have done that. Even the triangle, even the angles that you created would still form a triangle. If they didn't, double check your work because it should have, because that is a really important theorem. Let's move on to the are you ready for more before we summarize and do our cool down. I still really like this activity. If you would like to see this pattern continuing, draw a quadrilateral. This is a 4-sided figure. Draw a quadrilateral, tear off its angles, and line them up. What do you notice? Pause the video now, make your own quadrilateral, cut off those corners, and line them up. What's happening? I am going to take advantage of not drawing and just using post-it notes to finish up this activity. Here is a quadrilateral. It does have 4 sides. Now I know this isn't very entertaining, but I'm going to demonstrate with the simple one first. Cutting off the corners. Again, I'm not worried about anything else with that quadrilateral, so I'm just going to go ahead and put that off to the side. Here's the 4 corners, lining them up. You can see there's the 180 degrees of a triangle, but I still have 4 more corners, or 2 more corners. Here is the next corner. And here is that final corner. What angle is that? If we start here and count all the way around, there's our 180, 90 more for 270, and 360. So this quadrilateral was 360 degrees. Let's try something else. I'm going to take my post-it note and I'm going to cut it into a different type of quadrilateral. We'll make it a little bit more interesting. All right, here's my next attempt at a quadrilateral. 1, 2, 3, 4. Very interesting shape. Definitely doesn't look anything like we saw before with the square. I'm going to start by marking these angles so that I cut them off. I still know what angles I'm supposed to be looking at. All right, see if this can work for me. Looks like again, I have 360 degrees. Did it work for your quadrilateral too? Try a different odd shaped, try a parallelogram, try a rhombus, try a trapezoid, try any other weird shaped quadrilateral and you'll get the same result. So all of the angles in a quadrilateral will add up to be 360 degrees. Let's move on to our summary now. A 180-degree angle is called a straight angle because when it is made with two rays, they point in opposite directions and form a straight line. That's what I showed you in the beginning. I had this angle formed and I continued to rotate this around until it was 180 degrees and formed a straight line. If we experiment with angles in a triangle, we find that the sum of the measures of the three angles in a triangle is 180 degrees, the same as a straight angle. This is so incredibly important. This is a theorem that has its own name. I'm going to highlight it and I'm going to add some extra information. This is called the triangle sum theorem. Perhaps it's something that you already knew. It is a very important theorem that is going to help us out in our future mathematical practice in proving so many other things. Through experimentation, we find if we add the three angles of a triangle physically by cutting them off and lining them up, just like we did in our exercise yesterday, we can see that those three angles form a straight angle. We can see it color-coded down below. We have this triangle with a red, a blue, and a green angle. We can cut off those and you can see here's the blue, here's the red, here's the green, and all together they do form a straight angle of 180 degrees. We also saw the converse. If we have a line and two rays, so in other words, we have our straight angle. There it is. We can split it up to form three different angles. And then those three angles can be used to make a triangle. Again, we have blue plus red plus green is 180. So we can see blue, green, and red all add up to be 180. Yes, we might have to extend some side lengths in order to actually form the triangle, but we can form a triangle with those angles. Adding to our glossary term is straight angle. I also would like you to include triangle sum theorem. That is the name of this theorem. And now it is time for your cool down. In triangle ABC, the measure of angle B is 50 degrees. So maybe let's draw a sketch. It doesn't have to be perfect. It's just a sketch. But I am going to draw a triangle that has an angle of maybe about 50 degrees. That would be B. It's called triangle ABC, so probably A, B, and then C. Give possible values for the measures of angles A and C. If ABC is an acute triangle, that means all of these angles would have to be less than 90 degrees. You can see I drew maybe an obtuse, maybe a right angle here. So again, this isn't a perfect sketch, it's just to help us visualize. So if each one of them has to be acute, that means each angle has to be less than 90 degrees. So what are some possibilities? Even though they have to be less than 90 degrees, it wouldn't be wise to choose measurements like 20 and 20 because all of these angles still have to add to be 180 degrees. 50 plus 20 plus 20 is only 90 degrees. That's not going to be big enough. So pick some angles that will still be less than 90 degrees but still add up to 180. For example, I might choose 80 and 50 because 50 plus 50 plus 80 is 180 degrees. But 80 and 50 are less than 90. I am having such a hard time writing this and symbol. There we go. Each of these are acute angles, but they still add up to 180 degrees. Part B. Give possible values for the measures of angle A and C if ABC is an obtuse triangle. This time, one of the angles would have to be greater than 90 degrees. So choose a number greater than 90, but still keep in mind that they all have to add up to 180 degrees. So it's probably not a good idea to pick a number like 160 because 160 plus 50 is way more than 180 degrees. So you can't just pick any number. You do need to make sure that you're picking a number that will still allow us to add up to 180 degrees. So 50 degrees, maybe I will choose 100 degrees. That's obtuse. And 100 plus 50 is 150. The other angle would have to probably be 30 degrees. Is that the only option? Nope, you have a lot more options. Number 3, give possible values for measures of angles A and C if ABC is a right triangle. That means for sure one of these angles has to be 90 degrees. So obviously I'm going to put in here a 90 degrees. Don't forget, we still have our 50-degree angle that it gave us in the beginning. So 50 plus 90, that means that the only other option for that third angle is going to have to be 40 degrees. 90 plus 50 is 140, plus 40 more is going to add up to be 180 degrees. That's it for today. Your homework is the Lesson 15 practice problems. Before I officially set you free, I do need to warn you that problem number 5 on your homework is a review of 7th grade material. From what I have heard from my in-person classes, it is material that they either never learned or that they forgot because spring was not kind to us. So here is your review of scale factor and scale drawings. We need to draw a scale copy of this quadrilateral using a scale factor of 1/2. Normally it would look something like this. It would be a nice rectangle with a side length of 4, 2, 4, and 2. And a scale factor of 1/2 means each one of these side lengths is half as big. This is 4. So a scale factor of 1/2 means that the new side length would be half of that, 2. This side length is 2. So the new rectangle that's a scale factor of 1/2, half of 2 is only 1. Continuing on, side length of 4, but half of 4 is 2. And at side length of 2, but half of 2 is 1. So there would be the scaled copy. This is a little bit more challenging because it's hard to know exactly how long these side lengths are. We have to use a little bit different strategy when looking at diagonals. When I go from A to B, I'm going up 2 and over 2. So in the scale copy, half of 2 is 1, so I'm going to go up 1. And half of 2 going across is 1 going across. So that diagonal AB is going to be half the size. And diagonal BC goes over 4 and down 2. So in the scale copy of half, going over 4 means that half of that I'm only going to go over 2. We went down 2, half of that means I'm going to be going down 1. There's that diagonal, BC. Continuing on, I can see that diagonal CD goes down 4 and over 4. Half of that will be down 2 and over 2, making the diagonal look like that. And finally, to finish up, this diagonal went down 4 and to the right 2. Half of 4 is 2, so I go down 2. Half of 2 is 1, so I go over 1. That completes that figure. Notice that these two figures look the same. They are not congruent because one is bigger and one is smaller, but they have the same general shape. Good mathematicians would also label this A prime, B prime, C prime, and D prime. Now, officially, that's it for today. The rest of the practice problems are also yours to complete. That's it. We'll see you next time.